Floor framing, as far as my experience, and I think as you as a homeowner, if you're kind of taking on a project on your own, I think it's something that you should be able to handle. When it comes to framing in general, usually when I get into like roofs and being up above ground, that's when I like to call in the professionals to deal with rolling trusses. But for this particular part, we're talking about framing floors. If you're willing to take on that side of it on your own, I think you should have no problems doing it. We kind of talked in the previous video about design, and what sizing is. And now I just want to talk about, the framing of it, the construction of it, and just some of those few little things to know about when you start diving into it. A floor system is pretty straightforward, right? It's like, okay, I've got 2x10s, I've got 2x8s, whatever it is. It's 16 inches on center. I roll them. If I've got an interior bearing wall, I splice them, nail them off, block it, put on your rim, and you're good to go, right? Put on your 3/4 inch or whatever it is you're using for your decking material. Usually I see like 3/4 inch with tongue and groove is usually what I see. 3/4 inch tongue and groove that's glued and nailed or screwed down. The glue will help with squeaks. So I've even seen glue put in the bottom of a joist hanger. So a metal hanger. I've seen contractors put a little bit of liquid nails or like a construction adhesive in like a little dap of it in the bottom, and then they'll set the joist in the hole, and it'll kind of just help that thing from squeaking. Because I know you can get your brand new floor done and there'll be a squeak down there and it'll drive you nuts. So glue it off the best that you can. But let's talk a little bit in the code book about like bearing and blocking and all that kind of stuff. Okay, so bearing, right? The ends of each joist, beam or girder, so maybe your floor system involves beams and girders. It says, shall have not less than 1.5 inches of bearing on wood or metal, and have not less than 3 inches of bearing on masonry or concrete. That should be pretty simple to hit, right? I mean, you're going to end up with your foundation wall. If you're pouring foundation walls and you're putting a floor on it, it's going to be, 6 inches typically minimum. So boom, you're good there. All your interior walls typically are framed out of 2x4 now these days. So there you go. You got 3.5 inches there. And that's on wood, not masonry or concrete. So you should be covered with the whole bearing thing right out the get-go. Now, if you're doing some other type of framing besides setting on top of the wall, if you're doing what they call like a balloon framing, where maybe you got 2 stories and you're just going to like nail your joist right to the studs, well, you can get into some more trickier situations with that and making sure you have proper bearing. I'll show you a little diagram that I have that I found that ICC provided. And hopefully that will give you a little direction if you're doing balloon framing. I don't see that a lot where we're at, and I don't even know that we allow it. Typically it's you frame your floor, or you frame your walls, frame your floor, build your next set of walls on top of that. Then you have a rim board that goes all the way around it, kind of pulls everything together. Floor system framing from opposite sides over bearing support shall lap not less than 3 inches. Okay, so if you have an interior bearing wall and you've got joists that come across and they splice across each other over that bearing wall, it needs to splice at least 3 inches. Okay, minimum of 3 10D face nails. So attaching that splice together. The joist framing into the side of a wood girder shall be supported by approved framing anchors or by ledger strips not less than nominal 2 inch by 2 inch. Usually we see joist hangers, just pretty straightforward. You're going to see if you're attaching to a beam, you're going to put a hanger in there, it's going to sit in the hanger. That's just kind of standard construction practice these days. So if you have a situation like that, so when we built our house, we didn't want any steps. And so we actually dropped the floor down into the crawl space. So I poured the foundation wall a little higher and I dropped the floor down into it. So I didn't have like a step walking into the house. And to do that though, I ended up having to put hangers everywhere, right? I had to drop everything down into it. And so all those floor joists sit in hangers. Right? And I put a little bit of glue in them and I dropped them in there and it just helped cut down on the squeaks. And it turned out great. Put my 3/4 tongue and groove down, and then you have on top of your foundation wall, you have your 1.5 inch treated bottom plate. and then the 3/4 inch going over the top of that. And so above my foundation wall, my floor only sat, you know, two and a quarter, what would that be? Yeah, 2¼ inches, which is great, right? So we set it up so that we had no steps walking into the house. A lot of people are working towards that these days. Maybe they're the older generation, or they just don't want to deal with steps, and it's just kind of a roll into the house, and you don't have to deal with steps. So take that into consideration. If you're doing any type of joist, even if it's just like a stair landing, and it's just butting to like a beam of some sort, just make sure you put hangers on it. Lateral supports. So joists shall be supported laterally at the ends by full depth solid blocking not less than 2-inch nominal thickness. Okay, so if you're doing a just standard floor system and it's sitting on top of the walls, you're going to end up putting up what they call like a rim joist, right? And it's going to go all the way around the entire floor system, and all of your joists would nail to it. It would sit on top of the wall, your joist, and then your rim would as well be flush with the exterior, and you're just going to nail it together. And then what about that splice though, right? Because that's an end, right? It says each end must be blocked. And so that in that particular case, you would end up blocking over the top of that interior bearing wall. And then obviously some of them get kicked out if you're running duct in there, or you got a plumbing pipe or something. Those types of trades will come in and they'll start beating all the blocks out of there. And, you know, we don't make them, obviously you can't put them back in if there's duct in there, but you would go in and install them all to start with, and then just take out what you need to run all your roughing in. Let's go over to some of these diagrams here. So they're talking about your subfloor. Here they're showing your joists with they call it a band, rim, or header joists. I call it a rim joist. You call it either of those. Kind of goes all the way around the outside, right? Picks up all the way around the outside is this rim. And then you've got your joist that sits on top of your wall and then gets nailed into the rim. And then right here you'd end up blocking in between all of this, right? Here they've shown kind of a detail. Maybe this is, they got a fireplace right here. So they have to do what they call head out the floor system. So they've doubled up along each side of it so that they can then run a cross joist to pick up these other interior joists running the same way. Now you'd end up putting hangers on all this. So you'd put a hanger here, and then all these joists that butt into it would have hangers as well. So it'd be quite a few hangers in that particular situation. Just make sure you plan accordingly and get the hangers that you need. Pretty straightforward stuff here, right? So you just talking about bridging between joists. You're going to end up blocking all of this, but pretty straightforward. There's just not a lot to it. Here would be kind of a different angle of looking at it. So here they're showing kind of, you know, the floor sits on top of the wall. You've got your band joist or rim or header joist, right? So it runs right along the outside. It's flush with the exterior, and then your joist sits on top of your wall and gets nailed into it. Here is kind of that balloon framing that I talked about. Maybe you guys are allowed to do it where you're at, and you're just going to put in these tall studs, right? You're going to get 20-foot studs, and then you're going to end up just running your floor joist. It's going to bear over the top of your interior bearing wall, and then it's just going to get nailed to the stud. So joist nailed to the stud, and then here they're asking for a 1-inch by 4-inch ribbon cut into the stud, which to me is a lot of legwork, right? You're going to go into that stud and actually cut a little crevice to inset a 1x4 at minimum, right? Maybe it's a 2x4 or something, and you're going to inset it in there. That's a lot of notching, but I can't say that it's not done. And so if it is, and you do that, then just know that you probably have to meet something along these lines for requirements. Again here, so you got a crawl space or a basement, same situation. You got your sill plate, you know, your treated sill plate, and you've got your rim, your band joists, and your joists just carry across, sit on top, and get nailed into it. Like I said, with my house, I dropped it down in, and so off this sill plate, I got a little bigger sill plate, so I was not rubbing on the concrete, and then I put hangers in here, and I just set my joists in, and just followed the pattern, and put it in, and voila, no steps. So anyways, that should cover the basis for construction on, or framing of a floor system. But let's look at a few pictures so you kind of know what I'm talking about besides just diagrams. So this would be I-joists. This would be a designed system. Okay, so here's your sill plate, here's your rim, and then here are your I-joists. They're just sitting right on top of it. They're getting nailed off into these top flanges, and there you go. This particular house right here was done with 2x10s, and they had to block over the top of their bearing points right here. And so just on the other side that's blocking is probably the splice on the other piece, right? The other going the other way on this section right here, sitting over the top of a beam. If it ran into the beam, if the beam was up in here, then they'd end up putting hangers on all of it. Here again is I-joists. So they've doubled up some I-joists in here. Maybe just that particular area had a lot of weight on it. They want to make sure there was no squeaks in it. And so they went in there and just doubled it up. But again, that's a design type situation. Here would be the same thing, just a different picture, different angle. And you can see they have an interior bearing header over the top of it so that it can span. You see they got even blocking inside all of here, all the blocking over your bearing points. Here's a section where they've they just, instead of cutting it, they just threw it in there. And they've definitely spliced over 3 inches, right? Made sure they got their 3 nails in there, blocked over the top of it. Here would be an example of like a complete floor system sitting on top of the foundation wall, carries across, it's got its blocking over its bearing point, and it's got its rim all the way around it. It's a little blurry there for you, but I think in the general sense you'll be able to understand what I'm talking about. I think that should cover it for pictures. There's an idea kind of on floor systems, so hopefully that helps you. Go get it, get her done, make it look good. Make sure you take a little extra effort and stop the squeaks before it's too late. Jump on your floor, move around on it, let it sit for a couple days when you're framing the walls on the upper floors, or check things. You might have to add a screw here or a screw there, and cut down on those squeaks. All right.